Angle bisectors. So we should remember from Unit 1 that an angle bisector is a ray that divides an angle into two congruent adjacent angles. And the angle bisector of a triangle is a segment that bisects or cuts in half one of the angles of the triangle. So if I had an angle bisector, it would cut these angles in half so that this angle would be congruent to this angle. So this angle is going to get cut in half, and this angle is congruent to this angle. And when you have an angle bisector of a triangle, it's always going to start at a vertex. Okay, it's never going to start anywhere else except for a vertex. And every triangle has 3 angle bisectors. Alright, so recall from the perpendicular and parallel lines unit that the distance between a point and a line is the length of the perpendicular segment from the point to the line. So if I have point P and I want to find the distance between P and line L, the shortest distance is going to be whatever segment, or whatever the length of the segment is, that is perpendicular. So this right here would be considered my distance. Okay, that's the distance from point P to line L. Now, why do we want to remember that? Because our angle bisector theorem tells us that if a point is on the bisector of an angle, then it is equidistant from the two sides of an angle. And the converse of our angle bisector theorem tells us that if a point is in the interior of an angle and it is equidistant from the sides of the angle, then it lies on the angle bisector of the angle. So here in this picture, if I call this point P, point P is in the interior of, let's say, angle ABC. It lies in the interior. And because it lies in the interior and it's obviously on this angle bisector, that means my distance PA is congruent to my distance or equal to my distance PC. Now, when I have 3 angle bisectors in a triangle, the point of concurrency is called the incenter. So here's one angle bisector. Here's a second angle bisector. Here's a third angle bisector. And they meet at this point right here. And that is called the incenter. And what is special about the incenter is that it is equidistant from the sides of the triangle. So if I go from this incenter and I find a perpendicular line from the incenter to the sides, then these 3 blue lines the distance from the incenter to the sides are all going to be the same. Okay? So that's the qualities of an incenter. Alright, let's do some examples. So, in example 1, we have been given that whatever point this is, it is the same distance from both sides of the angle. So what that means is it lies on the angle bisector. If it lies on the angle bisector, then these two are congruent. So those are equal. So you just set it up, 3x plus 5 is equal to 4x minus 6. And once you solve for x, you should get that x equals 11. Alright? These two lines here tell me that this is an angle bisector of this angle. And because I'm looking at the perpendicular segment, that means that these distances must be congruent. And therefore 6x minus 5 must be equal to 5x. So if 6x minus 5 is equal to 5x, then that means x equals positive 5. Alright, example 3. We want to find the measure of angle ABC if BD is an angle bisector of triangle ABC. So the measure of angle ABC is 4x minus 6, and I know that BD is an angle bisector, so that means this angle is going to be congruent to this angle. So I know that x plus 6 plus whatever this angle is equals 4x minus 6. But it's actually the same angle. So you can either write 2 times x plus 6, or you could say x plus 6 plus x plus 6. And that's going to be equal to my bigger angle of 4x minus 6. So now I've got 2x plus 12 is equal to 4x minus 6, and x equals 13. Alright, last example. CD is an angle bisector of triangle ABC, and I want to find the value of x if I know that angle BCA is 80. Well, if angle BCA is 80, then I know that half of angle BCA is going to be 40. So 3x plus 1 must equal 40, because this is my angle bisector. So these two sides are equal. So then I can solve for x, and you should get that x equals 13. Alright, we didn't talk much about incenters. We're going to be focusing on triangle centers a little bit more on Monday, all 3 of the triangle centers. So just make sure you look at that foldable that I gave you.